Hello everyone, welcome to this session of AWS Core Services overview. In this session, we'll get a high level yet deep understanding about some AWS Core Services like EC2, S3, RDS, IAM, and Route 53. So before starting the session, a brief introduction about myself. My name is Raahat Varma. I am an intern at Training Delivery AWS at Athnas. I am 3x AWS certified and a Aviatrix certified engineer. So this is the agenda of this session. We'll get an overview of AWS, what is AWS Amazon Web Services, why to choose Amazon Web Services over any other cloud provider. We'll get a high level understanding of AWS Core Services, that is Amazon IAM, Amazon EC2, Amazon S3, Amazon RDS, and Amazon Route 53. So what is Amazon Web Services? Amazon Web Services AWS is the world's most comprehensive and broadly adopted cloud platform. In 2006, AWS began offering IT infrastructure services to business in the form of web services, now commonly known as cloud computing. So AWS has more than 200 services offered. AWS provides a highly reliable, scalable, low-cost infrastructure platform in the cloud that powers hundreds of thousands of businesses in 190 plus countries around the globe. AWS is architected to be the most flexible and secure cloud computing environment available today. So this is the AWS Global Infrastructure. It has 26 launched regions with multiple availability zones. So the regions are the clusters of data centers. Each region has maximum of 3 availability zones. As you can see in the picture, the blue dots are the regions available and the yellow dots are regions coming soon. AWS has 84 availability zones around the globe. It has 310 points of presence or edge locations as well. So why choose AWS? First of all, AWS is leading cloud service provider in the cloud market. It has around 33% of market share. AWS offers low pay-as-you-go pricing with no upfront expenses or long-term commitments. You pay only for what you use. It is scalable and supports high performance. AWS provides a massive global cloud infrastructure that allows you to quickly innovate, experiment, and iterate. Instead of waiting weeks or months for hardware, you can instantly deploy a new application, instantly scale up as per your workload requirement, and instantly scale down based on the demand. Whether you need one virtual server or thousands, whether you need them for a few hours or 24/7, you still pay for what you use. So this is a benefit of AWS. AWS offers flexible environment. AWS is a language and operating system agnostic platform. You choose the development platform or programming model that makes the most sense for your business. You can choose which services you use, one or several, and choose how you use them. This flexibility allows you to focus on innovation, not infrastructure. So we have come to the first core service, that is AWS Identity and Access Management IAM. AWS IAM provides fine-grained access control across all of AWS. So you can create users, IAM users, you can create groups, you can add those users to the groups, and you can add specific permissions for each user or each group to allow a particular service or not. With IAM, you can specify who can access which services and resources under which conditions. IAM is an AWS service that is offered at no additional charge, so IAM is free. So it is the best practice to use your root account to create an IAM user and do the rest of your work as a IAM user, not a root account, not a root user. So it is the best practice considered in AWS. So how IAM works? AWS IAM, you have to apply fine-grained permissions to AWS services and resources. Who can access those permissions? The workforce user with AWS SSO or the workloads with IAM roles. So they can access the permission. They can access the services or resources with proper IAM policies that are JSON-based policies, and the resources are within your AWS organization. So why use IAM? So why to use IAM? Number one point is fine-grained access control. So you can grant access to specific AWS service APIs and resources by using IAM policies. You can define specific conditions in which access is granted, such as granting access to identities from a specific AWS organization or access through a specific AWS service. Number two is delegate access control by IAM rules. So what is IAM rule? An IAM role is an identity that you can create in your account that has specific permissions. An IAM role is similar to an IAM user in that it is an AWS identity with permission policies that determine what the identity can and cannot do in AWS. Number 3 is IAM Assess Analyzer. So achieving least privilege is a continuous cycle to grant the right fine-grained permissions as per your requirements evolve. So IAM Assess Analyzer helps you to streamline permissions management as you set, verify and refine permissions. Last is permission guardrails with AWS organizations. So with AWS organizations, you can use SCPs or service control policies to establish permission guardrails that all IAM users and roles in organization account adhere to. So that was it for the IAM. So we'll now move to the demo of IAM. So we'll create a user and we'll create a group. We'll add the user to the group and we'll attach a specific permission to the group and test our IAM user. Welcome to the demo of AWS IAM. So we are in the AWS Management Console. So this is what a console looks like. So we'll search here IAM. So we are here in the IAM dashboard. So we'll go to users. As you can see, the 3 users are created: user 1, user 2, user 3. So they are not added in any of the groups. So now we'll go to the groups, user groups, and we can see the 3 groups are created: EC2 admin, EC2 support and S3 support. So we'll do our demo with the third group, S3 support. So we'll open it. We'll go to the permissions and you can see the Amazon S3 read-only access policy is attached to the this group. So it is AWS managed policy. So it is default created by AWS. So when we open the policy, so you can see it says the effect allow action is get S3 list, S3 object lambda get, S3 object lambda list. So this policy means that the user has only access to S3, so it can't access any other services. So we'll test it out. So we'll click here users. We'll add the user 1 to the S3 support group. So the user 1 is added to this group. Now we'll test our user. So we'll go to dashboard. Here on the right hand side there is a sign in URL for IAM users. So we'll copy this. We'll open a new tab. We'll paste the link. We'll write user 1 and the password. So we are logged in as the IAM user 1. So this user has the S3 read-only access. So we'll go to S3. Now as you can see, there is a sample bucket created here in S3 and we can view it. So the user has the S3 read-only access. Now the user cannot access any other services. So we'll try EC2. We'll write EC2 here. As you can see, it says you are not authorized to perform this operation because the user only has the S3 read permission, so he can't access any other services. So this is the benefit of IAM. You grant your user the permission he needs. So this is known as least privilege. You only give the permissions that are required. So this is the end of the demo of AWS IAM. Now we'll go to AWS EC2. So this is the second core service, that is Amazon Elastic Cloud Compute or Amazon EC2. Amazon EC2 is a web service that provides secure, resizable compute capacity in the cloud. Amazon EC2 offers the broadest and deepest compute platform with over 500 instances and choice of latest processors, storage, networking, operating system, and purchase model to help you the best match the need of your workload. Amazon EC2 simple web service interface allows you to obtain and configure capacity with minimal friction. It provides secure compute for your applications. The security is built-in foundation of Amazon EC2. It helps in optimizing cost and performance by using AWS spot instances or AWS saving plans. It provides you the complete control of your computing resources and lets you run on the Amazon proven computing environment. So this is the basic EC2 flow. So first of all, you have to find an AMI, that is Amazon Machine Image. So you can customize an existing AMI or build an AMI from scratch. So AMIs are available by default also in the EC2 console, or you can get the AMI from AWS Marketplace. So you have to bundle your AMI. You have to launch your instances. You launch instances of your AMI and administrator and use your instances. So we'll create an instance in the demo for more clarity. So these are the EC2 instance types. So there is M and T family, that is general purpose, the C family, that is compute optimized, the R, X, Z family, that is memory optimized, and the DHI family, that is storage optimized. So the general purpose, that is M and T family, general purpose instances provide a balance of compute, memory, and networking resources and can be used for a variety of diverse workloads. These instances are ideal for applications that use these resources in equal proportions, such as web servers and code repositories. Now the second is compute optimized, the C family. These are ideal for compute bound applications that benefit from high performance processors. Instances belonging to this family are well suited for batch processing workloads, media transcoding, high performance web servers, high performance computing HPC, scientific modeling, dedicated gaming servers, and ad server engines. Also machine learning, inference, and other compute intensive applications. Now the third one is memory optimized, that is RxZ family. Memory optimized instances are designed to deliver fast performance for workloads that process large data sets in memory. The last is storage optimized, the DHI family. Storage optimized instances are designed for the workloads that require high sequential read and write access to very large datasets on local storage. They are optimized to deliver tens of thousands of low latency random I/O operations, IOPS, to applications. Now we have come to EC2 pricing. So EC2 has 4 pricing models: on-demand instances, reserved instances, spot instances, and dedicated host. So on-demand instances, you pay for the compute capacity by hour or the second depending on which instances you run. There are no long-term commitments or upfront payments. You can pay the specified hourly rates for the instance you use. Application with short-term, spiky, or unpredictable workloads that cannot be interrupted use this on-demand instances. You can also increase or decrease your compute capacity depending on the demands of your application. Second one is reserved instances. So reserved instances provide a significant discount up to 72% compared to on-demand instances. So there is a commitment, 1 or 3 year commitment, and up to 72% discount. Reserved instances are assigned to a specific availability zones. They provide a capacity reservation, giving you additional confidence in your ability to launch instances when you need them. Number 3 is spot instances. So spot instances allow you to request spare Amazon EC2 computing capacity and up to 90% discount compared to on-demand. So these are recommended for bad jobs when data is not critical, applications that have flexible start and end times, applications that are only feasible at very low compute prices. The last one is dedicated host. So it is a own private physical EC2 server and it is expensive. A dedicated host is a physical EC2 server dedicated for your use. Dedicated host can help reduce costs by allowing you to use your existing server-bound software licenses, including Windows Server, SQL Server, and SUSE Linux Enterprise Server, and can also help you to meet compliance requirements. So now we'll move to the EC2 demo. Welcome to the EC2 management console. So from here we'll create a first instance, a web server instance, and we'll install a PHP application in it. So to create an instance, you have to launch instance here. So this is a AMI, Amazon machine image. So you can choose from a various machine image here. So I will be choosing this Amazon Linux 2 because it is free tier eligible. Now we'll choose the instance type. We have learned earlier about the instance families. So I'll choose the T2 micro because it is free tier eligible. It has 1 vCPU and 1 gigs of memory. Now we need a one instance. So the VPC will be the lab VPC. I created it. The subnet will be public subnet. The auto sign IP will be enable. Now in the advanced details, you can see user data. So I have a script here. So this is a script. This script installs a PHP application on a web server. So we'll copy this script. We'll paste it here. Now next, we'll add a storage here. So we are using the general purpose SSD2, that is 8 GB of storage. We don't need to add tags. So now we'll configure a security group. So what is a security group? Security groups are at instance level. So they control the inbound and outbound traffic of your coming to your instance. So we'll select an existing security group. I created this web security group earlier. So it enables the HTTPSS at port 80, the sources from anywhere. So we have to choose a key pair for an instance. So it is a private key file. So I have already created a key file. So I'll choose this only. This is just a demo how you can create a EC2 instance. So you can use the default VPC, default subnets. You can create your own private key that can be a PPK file or the PEM file. So as you can see, our instance is created now. It is in pending state. So we'll name this instance. So I have named this instance. Now we have to wait for the status checks. So as you can see, our status checks have passed. So I'll just refresh it. So to test a web application, what you have to do is we have to copy this public IPv4 address, paste it in a new tab. So you can see this is our sample PHP application. It displays some data, metadata and value, instance ID, and which availability zone are instances. So this is a sample application. Now you know how to create a EC2 instance. So we'll go back to S3 now, Amazon S3. So we are on the third service, that is Amazon Simple Storage, Amazon S3. It is one of the building blocks of AWS. So it is a cloud object storage offering. This is the object storage built to retrieve any amount of data from anywhere. So it is virtually unlimited, scalable, and it supports high performance. You can protect your data with unmatched security, compliance, and audit capabilities. You can scale your storage resources to meet the fluctuating needs with 11 nines of data durability. You can reduce the storage costs by storing data on various S3 storage classes. And you can also use S3 to host static websites. So how S3 works? So first of all, you have to move your data to Amazon S3 wherever it lives in the cloud, in the applications or on-premise. So Amazon S3 object storage built to store and retrieve any amount of data from anywhere. Amazon S3 is a object storage service offering industry-leading scalability, data availability, security, and performance. Customers of all sizes and industries can store and protect any amount of data for virtually any use case, such as data lakes, cloud-native applications, mobile apps. With cost-effective storage and easy-to-use management features, you can optimize cost, organize data, and configure fine-tuned access controls to meet specific business, organization, and compliance requirements. So these are some use cases of S3. You can use S3 to build data lakes. You can run big data analytics, artificial intelligence AI, machine learning, and high performance computing HPC applications to unlock data insights. Second is you can backup and restore critical data. You can meet the recovery time objectives RTO, recovery point objectives RPO, and compliance requirements with S3 robust replication features. Number 3 is you can archive data at lowest cost. So you can move data to Amazon S3 Glacier storage to lower cost, eliminate operational complexities, and gain new insights. The last one is you can run cloud native applications. So you can build fast, powerful mobile and web-based cloud native apps that scale automatically in a highly available configuration. So these are some S3 storage classes. So S3 has 7 types of storage classes. Number 1 is Amazon S3 Standard. So S3 Standard offers higher durability, availability, and performance objective storage for frequently accessed data. Because it delivers low latency and high throughput, S3 Standard is appropriate for a wide variety of use cases, including cloud applications, dynamic websites, content distribution, mobile and gaming applications, and big data analytics. Number 2 is Amazon S3 Intelligent Tiering. So it is the first cloud storage that automatically reduces your storage costs on a granular object level by automatically moving data to the most cost-effective access tier based on access frequency without performance impact, retrieval fees, or any operational overhead. S3 Intelligent Tiering delivers millisecond latency and high throughput performance for frequently, infrequently, and rarely accessed data in frequent, infrequent, and archive instant access tiers. Next is S3's infrequent access. So S3 Standard IA is for the data that is accessed less frequently but requires rapid access when needed. S3 Standard IA offers high durability, high throughput, and low latency of S3 Standard with low per GB storage price and per GB retrieval charge. This combination of low cost and high performance makes S3 IA ideal for long-term storage. Number 4 is Amazon S3 One Zone IA. So Amazon S3 One Zone IA is for the data that is accessed less frequently but requires rapid access when needed. So the data is only stored in one availability zone in One Zone IA. Next is Amazon Glacier Instant Retrieval. So we have came to the archive storage classes now. So number 1 is Amazon Glacier Instant Retrieval. So it is an archived storage class that delivers the lowest cost storage for long-lived data that is rarely accessed and requires retrieval in milliseconds. With S3 Glacier Instant Retrieval, you can save up to 68% on storage costs compared to using the S3 IA storage class when your data is accessed once per quarter. S3 Glacier Instant Retrieval delivers the fastest access to archive storage with the same throughput and millisecond access as the S3 Standard or S3 Standard IA. Then is the Amazon Glacier Flexible Retrieval. S3 Glacier Flexible Retrieval delivers low cost storage up to 10% lower cost than S3 Glacier Instant Retrieval for archive data that is accessed 1 or 2 times per year and retrieved asynchronously. For archive data that does not requires immediate access but needs flexibility to retrieve large datasets at no cost, such as backup or disaster recovery use cases. S3 flexible retrieval, that is formerly S3 Glacier, is an ideal storage class. Then is Amazon S3 Outposts. Amazon S3 Outpost delivers object storage to your on-premise Amazon S3 Outpost environment using the Amazon S3 APIs and feature available in Amazon regions today. S3 Outpost makes easy to store and retrieve data on your outpost as well as secure the data, control access, tag and report on it. Now we'll move to the demo of Amazon S3. So we'll add some objects in the bucket and we'll host a static website on S3. Welcome to the demo of S3. So in S3 we'll create a bucket, we'll add some objects to the bucket and we'll host our static website on S3. So to create a bucket you have to click this. So the bucket name must be globally unique, so two buckets can't have the same name. So if a bucket name if a bucket dev is already created, so I can't create a bucket with the name dev. So I'll create the bucket name website 334. So there is no bucket as website 334, so we can create this bucket. The US AWS region will be US East 1. The object ownership will be ACL enabled and the object ownership will be bucket owner preferred. So I own this bucket. So I have to uncheck the block all public access because I am creating a static website, so I need the public access. So this setting is enabled by default. So we'll add a tag here. Now we'll create a bucket. So you can see the bucket with the same name already exists, so I can't create the bucket website 334. So I'll have to change the name. So yes, I am able to create the website 339 bucket because there was no bucket name by the website 339mail. So I'll open this bucket. Now I will upload the objects to this bucket. So these are the three files: index.html, script.js and style.css. So I have uploaded the files here. Now our bucket has these three files. We'll go to the properties of the bucket. We'll scroll down and you can see a static website hosting option, so you have to enable it. The index document will be index.html and the error document will be error.html. So yes, our static website hosting is enabled now. Now we can see a bucket website endpoint, so we'll copy this and we'll see if our website is working or not. So as we can see a 403 forbidden error because we have not made our objects public. So to make it, we have to go back to the bucket. We have to go to objects. We have to select the three objects. Click on Actions tab and make public using ACL. So yes, our objects are now public. Now we'll go back to the link and we'll try to refresh it. And yes, as you can see, our website is public now, so we can see our website. So this was the static website we just created. So this was the end of the S3 demo. Now I'll meet you in Amazon RDS. Welcome to Amazon RDS, that is Relational Database Service. So it is a fully managed relational database service by AWS. So it reduces efforts by automation. You can remove time-consuming database administrative tasks without needing to provision the infrastructure. You can deploy and scale database engines of your choice in cloud or on-premise. You can achieve high availability with RDS multi-AZ deployments. It supports MySQL, PostgreSQL, MariaDB, MongoDB, etc. And you can also scale the databases in cloud. So how RDS works? RDS is a collection of managed services that makes it simple to set up, operate, and scale databases in cloud. We can choose from 7 popular engines that are Amazon Aurora with MySQL compatibility, Amazon Aurora with PostgreSQL compatibility, MySQL, MariaDB, PostgreSQL, Oracle, SQL Server, and deploy on-premise with Amazon RDS on Outposts. So these are some use cases of the Amazon RDS. So you can build web and mobile applications. It supports growing apps with higher availability, throughput, and storage scalability. It takes advantage of flexible pay-per-use pricing to suit various application users patterns. Second is move to managed databases. You can innovate and build new apps with Amazon RDS instead of worrying about self-managing your databases, which can be time-consuming, complex, and expensive as well. The third one is break free from legacy databases. So free yourself from expensive, punitive commercial databases by migrating to Amazon Aurora. When you migrate to Amazon Aurora, you can get the scalability, performance, and availability of commercial databases at 1/10 of the cost. So Amazon Aurora is the serverless offering by AWS. Now in the demo of RDS, we'll learn how to build an RDS server with MySQL engine. So I'll meet you in the demo. Welcome to the demo of RDS. So in this demo, we'll see how to create a RDS database. So first of all, we need to create a security group for the database. So we'll go to VPC. We'll choose security groups here. And we'll create a DB security group, database security group. Description will be permit access from web security group. The VPC will be lab VPC. Now we have to add an inbound rule. The inbound rule will be MySQL. The port will be 3306 and the source will be our web security group. So this web security group lab VPC are pre-configured configurations for the purpose of this lab. So you can create your database in your own VPC as well or in the default VPC as well. But just make sure you have to write the inbound rule MySQL/Aurora. Now we'll create the security group. We will go to RDS. Now we have to create a subnet group here, a DB subnet group. We'll go to subnet groups, create, name will be DB subnet group. Description will be also the same. VPC will be lab VPC. The sub availability zones we'll choose is 1A and 1B. The subnets we'll choose is 0.3.0/24 and 0.1.0/24. These two subnets we'll choose. So our DB subnet group is created. Now the main task is to create a database. So after this tutorial, you will know how to create a database. So click here. Database creation method will be standard. Engine options will be MySQL. I will choose this one, MySQL. Templates will be of production. Availability and durability will be multi-AZ database instance because we need this for high availability and disaster recovery. Database instance identifier will be lab db. You can choose to write any name. Master username will be main. Password is lab password. So you can choose your master username and master password as well. I'm just writing the default one. The instance configuration will be burstable classes. So you can choose from standard classes, memory optimized classes, and the burstable classes. So I'm choosing the DB T3 micro, which 2 vCPUs, 1 GB RAM, and network speed of 2085 Mbps. Storage, I'll choose the GP2. So you can choose IO1 and magnetic. The allocated storage will be 20 GB. In the connectivity, I will choose lab VPC. Subnet group is already chosen. In the security group, I'll choose the security group I created, the DB security group. In the additional configuration, I'll write the initial database name as lab because my database identifier was labdb. I'll uncheck the automatic backups. I'll uncheck the encryption, and I'll uncheck the enhanced monitoring. So this will help me to create my database fast. So the estimated monthly cost comes to $29.42 USD. So yes, the databases are expensive, but so to create a database, just do these settings as per your requirement. Do the settings as per your requirement, and create database. So here the database has been created. It will take around 5 minutes to create a database. So this was the end of the demo. Now you know how to create a subnet group, how to create a security group, and also how to create a database. So I'll meet you in Route 53 now. Hello everyone. So we are at the last service, that is Amazon Route 53. Amazon Route 53 is a highly available scalable cloud DNS web service, that is domain name system. It is designed to give developers and businesses an extremely reliable and cost-efficient way to route end users to internet application by translating names like www.example.com into a numeric IP addresses like 192.0.21 that the computer uses to connect with each other. Amazon Route 53 is fully compliant with IPv6 as well. Amazon Route 53 effectively connects the user request to infrastructure running in AWS. Amazon Route 53 also offers domain name registration. So we are at the record types of Amazon Route 53. There are multiple record types, but we are covering these 5 important ones: A record, AA record, CNAME record, MX record, and alias record. So first one is A record. You can use A record to route traffic to a resource such as web server using an IPv4 address in dotted decimal notation. Next is AA record. You can use this record to route traffic to a resource such as web server using the IPv6 address in separated hexadecimal format. Next is CNAME record. A CNAME record maps the DNS queries for the names of the current record, such as acme.example.com, to another domain that can be example.com or example.net. So it maps the DNS queries from hostname to a hostname. Next is MX record. An MX record specifies the names of your mail servers, and if you have 2 or more mail servers, the priority order, each value of MX records contains 2 values, priority and domain name. The last one is alias record. So you can map the DNS to a specific AWS service. That can be S3 or that can be your Elastic Load Balancer. So we use alias record for that. Next are the routing policies available in Amazon Route 53. So there is simple routing, failover routing, geolocation routing, geo-proximity routing, latency routing, multi-value routing, and weighted routing. In simple routing, we use this for a single resource that performs a given function for your domain. For example, a web server that serves content from the example.com website. Next is failover routing. We use when we want to configure active passive failover. Next is geolocation routing. We use it when we want to route the traffic based on the location of our users. Next is geo-proximity routing. We use this when we want to route the traffic based on the location of our resources and optionally shift traffic from resources in one location to resources in other location. Next is latency routing. We use this when we have resources in multiple AWS regions and we want to route the traffic to the region that provides the best latency with less round trip time. Then is multi-value routing. We use this when we want Route 53 to respond to DNS queries with up to 8 healthy records selected at random. And last is weighted routing policy. So we use this to route traffic to multiple resources in proportion that we specify. Now the benefits of using Route 53. So number one is highly available and scalable. Amazon Route 53 is built using AWS highly available and reliable infrastructure. The distributed nature of our DNS server helps ensure a constant ability to route your end users to your application. Next is flexible. Amazon Route 53 traffic flow routes the traffic based on multiple criteria such as endpoint health, geographical location, and latency. We can configure multiple traffic point policies and decide which policies are active at any given of time. We can create and edit traffic policies using the simple visual editor that in the Route 53 console, AWS SDKs, or Route 53 API. Next is designed for the use with the other AWS services. Amazon Route 53 is designed to work well with the other AWS features and offerings. We can use Route 53 to map domain names to our EC2 instance, S3 buckets, CloudFront distribution, and other AWS resources. By using AWS IAM service with Amazon Route 53, we get fine-grained control over who can update our DNS data. We can use Route 53 to map our zone apex to our ELB instance, Amazon CloudFront distribution, Elastic Beanstalk environment, API gateway, VPC endpoint, or S3 website bucket using the feature called alias record. Next is it is simple, fast, and cost effective. So with the self-service sign up, Amazon Route 53 can start to answer our DNS queries within a minutes. We can configure our DNS settings with the AWS Management Console or our easy-to-use API. Using the global Anycast network of DNS servers around the world, Route 53 is designed to automatically route our users to optimal location depending on the network conditions. And Route 53 passes on the benefits of AWS. We only pay for the resources we use, such as number of queries that the service answers for each of our domain hosted zones, for managing domain through the service, and optional features such as traffic policies and health checks, all at low cost without minimum usage commitment or any upfront fees. So this was the end of the session. Thank you for joining this session. In this session, we learned about the AWS high-level understanding of AWS Core Services and hope you enjoyed it. Thank you and happy learning.